All right, guys, welcome to the Ravit Show. I am super excited for today's show. We have amazing data engineers joining us. I am calling this Data Engineers Roundtable, and I would like to thank Bigeye for such a great opportunity to bring all the great data engineers under one roof to discuss the importance of the topic data reliability and data observability here today. Please let me know where you're joining from. And some great news that I have for you is Bigeye is also giving away their swag. So what you guys just need to do is type in hashtag Bigeye in the chat and you will enter the raffle. Let me show what you guys need to type in just to make sure no one types it wrong. So this is what you guys need to type in the chat, and you will start entering the raffle. Towards the mid of the show, we will definitely, what we'll be doing is announcing one winner, and towards the end of the show we'll be announcing another one. So stay tuned, ask questions. We'll be not only just discussing about data reliability and data observability, but also anything around data engineering. This will be super fun. Let's welcome our guest. Without any further ado, let's start with Egor here. Egor, I'm just adding up all the engineers that we have, and then we can start with the introductions. Let's have Adi here. Hey, Adi, welcome. Joy and Matt are here, so I'm very happy Matt also joining us. It's not only Joy, but it's more like the Monday data morning show, data nerd
It's
show.
great to be here. What's up?
It will be fun, and I can't wait to invite him. Seattle data guy, Ben.
Hey.
Welcome. Welcome again,
Hey.
I might say.
It's been a while. Yeah. Good to see you all.
Been a while. And the great things that you've been doing, obviously your YouTube has grown like anything. We've been enjoying all the videos that you've been creating. So thanks everyone. You're joining us. We have a lot of folks already joining us, and thanks everyone for joining us today. Like I mentioned, yes, Bigeye, we are giving away the swag today. So feel free to type in hashtag Bigeye. But for all the folks here, I'm sure you would want to learn more about each individuals and each data engineers sitting here. So why not we start with the introductions and go from my left to right. So Egor, maybe you can start with your introduction and then move.
Sure, I'd be happy to. Thanks a lot for putting this together, Ravit. I'm really excited, and this is bound to be a great panel. Hi, everyone. I am Egor. I'm the co-founder and CTO here at Bigeye. Bigeye is a data observability platform. We help you look at your data and let you know when it looks not fit for use, so you can do something about it before your business finds out about it. Before starting Bigeye, I was a data engineer at Uber. I was one of the first people called a data engineer and did a little bit of everything from infrastructure, ETL, data modeling, BI, so on and so forth. And going back even further, I've been a software engineer my whole career, but I've fallen into the data space once Hadoop started getting big, and I wrote like MapReduce jobs, and I really got into the whole analytics and data infra side of things, and from there jumped into data warehousing, and that's how I started down my path.
Awesome. Thanks for that introduction, Egor. Adi, what about you?
Thank you so much, Ari. It's great to be here and lovely to meet everyone on this panel. So hi, I am Adi. I am leading the DevEx team at Treeverse, contributing to the open source Lake FS. And together with a lot of the folks here today, we're working towards influencing the future of data technologies and the developer experience for hands-on data platform builders. I met Hadoop back in 2013, writing multiple MapReduce as part of a research work in machine learning, trying to incorporate Mahout into and leveraging Mahout and writing MapReduce back then, and also later on continuing developing that aspect into Spark and building infrastructure for big data. So I'm super excited to be here today and work with you all to define the future as we see it.
Wow, can't wait to hear you, Adi, and maybe it's Joy, Matt. What about you guys?
Hey, what's up? I'm Joe.
I'm Matt.
Amazing. So yeah, we're Ternary Data. We're a data engineering consulting firm based in the US. I guess we both call ourselves recovering data scientists as well. So yeah, that influenced much of why we're in data engineering today. We're also the authors of Fundamentals of Data Engineering coming out this summer on O'Reilly. So happy to be here. Yep.
Yeah, and I would say, I mean, just seeing what was happening in the data engineering space, the evolution away from Hadoop toward cloud was part of what motivated us to start our company.
Yep.
Wow, this is amazing. I know for a fact where, Joey, I'll have a lot of questions around your book, and I'm sure the folks who are joining us today as well, they have a lot of questions and a lot of book recommendations that they would be needing. I know Adi's writing a book too, so definitely there are many more questions coming around that. Maybe, Ben, what about you?
Yeah, I mean, just kind of data, currently mostly focusing on, like, again, data engineering consulting. Also, like you referenced earlier, putting out videos on the Seattle Data Guide channel on YouTube. And then before that, working at Facebook as data engineer and kind of in startup world data engineering. I think, like many people, kind of initially influenced by the data science space early 2013, and then eventually was like, nah, I prefer data engineering. So then, yeah, that's kind of my general background as well.
That's so cool, Ben. Thanks for that. Also, I know for a fact where, there's something which is very common here, which is data engineering. And all of us here, I'm sure I have this question. I'm super curious. I go out there and ask each data engineers that, why is this space suddenly getting so hot? Or was it always hot and now it's kind of, picking it up because people are talking more about it? So would love to hear your thoughts. Maybe Adi, you can start first.
Yeah, so from my point of view, I see kind of an evolution. It's a mixture of analytics, machine learning, data scientists, data engineering. And slowly, as our ecosystem progresses, what I've seen with different customers and different community members that I work with, and also in the data engineering Slack community, is slowly people figuring out that in order to build good reports for analytics or take actions based on data or building machine learning models to automate that process, we need good data infrastructure. And it's kind of the area that people tend to miss. There was a lot of investment in machine learning, and a lot of great data scientists were hired either from academia or other places, but there wasn't enough attention to the data infrastructure and the data platform to enable them healthy access to fresh data, or fresh, good, high quality data. And so now slowly the industry kind of, looping back saying, hey, we want to enable all this great analytics. We want to do data-driven decisions. We want to we want to take business decisions and grow our business. And for doing that, we need data and we need the infrastructure. Yeah, this is how I see it. I'd love to learn how you see it.
Yeah, fair enough. What do you think, Joey, Matt?
Well, to echo what Adi was saying, I think we noticed situations where data scientists were hired, but there was no data upon which to do the science. And so, again, I think there was just a huge groundswell of interest in data science, which I think is awesome, right? It's, but what I think a lot of companies, feel free to chime in on this, but it's the foundation wasn't there, right? And so that's what data engineers are to build, is the foundation upon which you can do the analytics and the data science. So anything to add there, Matt?
Yeah, and I would say specifically, I think a lot of people who've been in the space for a while had the experience of dealing with Hadoop a few years back. So the barrier to entry was very high. You were either writing MapReduce jobs or trying to debug pig jobs or something. And now the tools have gotten way, way better in the sense that it's way, way easier to just do basic data processing than it used to be. But we still have these core issues of moving data in, and data reliability and data observability. So loop back to the theme of this discussion, like, you still have to have quality data no matter how good your tools are, or you're not going to get good insights.
Really, Matt?
Fair enough. What about you, Ben? What do you think about it?
Yeah, I mean, I think there's definitely a few different things that have kind of pushed for data engineering to kind of become more popular. We've spent like the last few years trying to get value out of data. Since the HBR article, everyone's trying to figure out how to do that. And then, eventually it was kind of putting the cart before the horse. situation where it was like everyone tried to build the models, and then while the maybe more big tech companies had already developed data infrastructure, and then we're kind of talking about the results. More other companies were like, well, let's just try to build the results, and then realized eventually it's like, okay, we need the infrastructure to support it. And then with tools, again, like referenced earlier, like cloud solutions that like actually made it possible to like process larger amounts of data or manage it more easily and not have to have like a giant team. All that kind of changes like just eventually led to this head where it's like, oh, we can start doing data engineering more seriously, but now we just need to find people that actually can do it. So I think that's kind of one of the other big pushes. It's just like the talent kind of gap for data engineering, since there's not a whole lot of training in the space. That tends to be kind of a general gap when it's like not in schools. There's literal master's degrees for data science at most of universities, but there's nothing in terms of training. There's usually like certificate programs I think I've seen, but other than that, it's like there's not like a direct path. It's like, okay, from here, this is how you become a data engineer. I think most people go either like the data analyst route to data engineer, or like software engineer to like data engineer, or some sort of more lateral growth path.
Wow, very interesting, those insights. Thanks for that. Also, Igor, where do you see it from a CTO's perspective, from a co-founder's perspective? It would be interesting to hear your thoughts.
Yeah, I would like to dig in a little bit more on what Ben said, because I think that's very relevant, which is data engineering grew out of the need to support the solutions that the businesses wanted to have. So I don't think data engineering is a new concept. I mean, if you look at organizations have been doing things with data and making decisions around data for as long as businesses existed. Finance has always been a very data-driven sales, finance, accounting. Like, this is just take the numbers, make a decision about what the business should do. How many people can we hire? How many sales? What is our sales forecast, and how fast can we grow in the next quarter or the next year? These are all applications of data. The interesting thing happened is when there was more data available and the business started thinking about new things to use data for. So even at Bigeye here, the bare bones data, if you think about it, is what's our revenue, what's our spend, and what does that mean in the future, and how do we project our growth and headcount and hiring plans. So businesses have been doing this forever, but now we're saying, okay, can we look at what features are popular based on who's using them and how often are they being used, and can we get some quantitative measures of people interacting with the product? And that's a natural evolution of, we have the data, now let's actually go do something interesting for the business. And that's where data engineering is necessary, is because once you get into that heterogeneity of the data, where there's just too many things for somebody to keep in their head, you need to start building systems and processes around.
Oh, that's very interesting answer there, Igor. Thanks for that. Also, in terms of, we have a lot of questions coming in, a lot of folks joining us. I just wanted to take this interesting question from the audience, and it is kind of very much related to the topic that we are here from Ravina Oswal on YouTube. What's the difference between data reliability versus data quality? It's a very interesting one. Anyone who wants to pick it first?
I can go. I get this question a lot. I feel like I get the question of, what is the difference between observability and reliability and quality, and which one do I care about and why? The way that I see it is, data reliability is talking about whether your data is fit for the needs that it is trying to address. So at the end of the day, data is used for something that a person will end up consuming. A dashboard, maybe it's going into a machine learning model for training, and that's influencing what product recommendations you're serving to users. And understanding whether that data is reliable enough to feed that product is what I would consider data reliability, and building the processes and using the tools necessary in order to ensure that and surface that. Data quality, in my mind, is a more point-wise operation of, there is a definition about what you mean about for a single piece of data to be high quality, whether that's a data set, a column, a row, whatever that may be. And you can define data quality, but then that needs to roll up into, well, if you have two tables feeding into a report and both of them are high quality, is it possible for the report to not be reliable? And the answer is yes, because the quality might not be measuring all of the aspects that you care about from an end product perspective, like such as latency, or do the join keys even match? Because if one side is high quality and there are unique IDs and there's unique IDs on the other side, but they're not joining out, your report's broken and not reliable. So that's how I see the split there.
And here's another way in which they're entangled. So data quality can drift. It's a huge problem. I mean, in the ML ops community, you see a lot of discussion of model drift, but data itself drifts, right? You have applications producing data, a lot of external sources, and the data can change. And so part of reliability is the consistency of the data quality, and also the ability to detect drift when it happens as the quality is going down.
Very interesting, those insights. Does anyone have anything more to add? Feel free to do so.
Yeah, I want to add data uptime. Sometimes when we work with distributed systems, we look at stochastic systems, right? It can be that at some point of time, we're losing one of the machines or something happened along the way. And so we'll have a data downtime and won't have access to the data at all, or have partial access to the data. Or sometimes engineers need to tweak some of the data that is available in production, or they're now deploying new business logic. And something happens. So I see data reliability also as a way to roll back into like the raw state in order to reproduce the logic to enable high quality of data for the data consumers. So this is another aspect of data reliability, in my opinion.
Fantastic. Thanks for those insights. They make sense. Okay, we'll take another question here from LinkedIn, and it's from Aditi. She's asking, we've heard a lot about end of ETL, and yeah, I've had a session with Detroit, and they mentioned about it too, where they are kind of focusing on the T from the ETL or the ELT. Can anyone share more light on this? Maybe Ben, Joy, you can give it a shot.
I think that the death of ETL is greatly exaggerated. And in fact, I would say with stream processing becoming more, I would say of a, I don't know if it's a central paradigm or it's more common workflows. Paradigm. Yeah, I actually think you'll just see more T, regardless of how you E or L it, for example. And so, but ETL, there's definitely some value to it. I would say, Matt, I think we riff on this a bit. What would you say are the benefits of doing ETL?
I mean, in general, and Bill Inman talks about this a lot, it's important to get your data into a shape where it's suitable for consumption. That's controversial because it is also important to be able to go back to the raw data and get insights there. But I think for especially a lot of business consumers, the data needs to be in a particular shape so they can get some consistent results out of it. The other thing I'd add in terms of quote unquote death of ETL is that part of what's happened is we've generalized our paradigms a bit. In other words, ETL is still there. It's just the whole transformation and pipeline process in the cloud is much less rigid than it used to be. And so it's not always explicitly extract, transform, load. It can be extract and load and then transform, or a variety of other flow patterns.
Extract and transform, load again, right?
Yeah, so exactly.
Yeah.
Okay. I mean, I think I'd probably parrot that similar feeling, right? And also like I feel like we get the death of XYZ for especially like in the data field, in any field, right? Like the death of whatever Angular. It's just a common thing, right? Like it's like, oh, this is going away. It's like it generally doesn't necessarily go away. At the most part, I think it tends to morph or change. Like referenced earlier, like okay, now some people are incorporating ELT instead of ETL. I still think I see plenty of ETL, especially at like larger companies. I think there's just a lot of different places where and I like the generalized component where it's like, even when I reference things often just as data pipelines, because to me it's like that could reference an ETL, it could reference an ELT, it could reference a stream, it could reference maybe something more that's on the integration side, just because it's like people have kind of taken different approaches, even in the same company, for doing similar work. I think you generally have more unified processes as you get like more data governance, but like especially like on the smaller scale of companies, like you'll see like they'll be doing like 2 or 3 different methods, depending on the team you're working with or something like that.
Well, now there's reverse ETL too.
And
so, then it kind of like came back in vogue and just backwards. I'm just kidding. But,
yes. Well, yeah, exactly. It's like, I don't know. To me, it's like it's not going anywhere. It's definitely something we still rely on, I think, heavily. And you're just gonna find people that have preferences. Like some people are like, I like doing the transformation in the code. I like doing the transformation, after it's loaded into the data warehouse. And sometimes it's just up to to a person or a team to decide kind of what they enjoy as well. And we could argue what's best, but like it's like the open source versus like picking a solution versus like building custom. It's like you always see people tend to lean towards one that they enjoy or they rely on or they believe is best. So I think that's always going to be dependent on people.
What are your thoughts, Adi?
Interesting. Yeah.
Yeah, I agree because I'm nodding. It's like all the reverse ETL, ELT, etc. I remember digging into all these aspects and trying to make sense out of them and kind of like classifying, categorizing them as we go to help people in the community learn more about the different aspects in data engineering. And yeah, I agree. I think it depends on the data platform that engineers are building at the end of the day. Like, how do they consume the data? How do they do the transformation? Do they need a pub sub mechanism or some kind of messaging mechanisms? Do they need the streaming processing? Or they're going completely with batch, and that's fine. I mean, what's the SLA for that data? What are the expectations? And also the notion of data product. What are the criteria for a good, healthy, working data product that engineers can engineer and also maintain for the long run? So I believe all of these different aspects is similar to what other people said here. We're building a data pipeline. It does transformation. It brings it from one state to the other state, and that's all good. That the underneath the hood, the thing that enables it to happen, that's all fine. It really depends on the picking the right solution, either a cloud solution, an open source solution, etc. But a high level perspective, this is a data pipeline. That's it.
Exactly. I like.
Yeah.
Oh, go ahead. Sorry.
No,
I was just going to say I like the term data pipeline because it encompasses everything. It's like ELT, ETL, reverse ETL. It's all just data pipelines if you think about it that way.
And there's also the risk of if you attach your whole process into a specific framework, you might be overcomplicating something that you don't need to. Because if you say, no, we have to do ELT or ETL or whichever you pick, you might make a solution that would have otherwise been very, very simple into something much more complicated than it has to be. And I feel like sometimes we as data engineers sort of miss the forest for the trees because we get so caught up in, we want to do it a specific way. And we forget that the only reason we're even doing this is so that somebody can use that data at the end of the day. And that's what we need to spend more time focusing on.
Agreed. Dogma is not a good thing.
Very true. I think, Egor, you've put it very well, and thanks for that. Also, we have a few comments here. Agree with Matt with the ETL, ELT, raw, etc. We need them all, but it can all be done one set with different routines. So yes, that's there. We have Tom is joining us. Thanks for joining us, Tom.
Hi, Tom.
Love your content there. Also, very quick question from my end, since we are also going a little back on the data engineering side. Since we are here, I know for a fact that we're talking a lot around data pipelines. We're talking a lot around ETL, ELT. We're also talking about data reliability, data quality. But when it comes to data engineers, what are the top skills that you would suggest that are way to go for any data engineers out there to upskill themselves and a must learn in 2022, at least in maybe the early 2023? I would ask that. So maybe, Egor, what do you think? Adi?
It's something that I feel like I've emphasized over and over again, especially as we were hiring folks at Uber and I was mentoring some more junior data engineers. Something that I kept pushing on, and this is going to be a nice transition from my previous comment, is understand what the business actually wants out of the data, and then tell me what solution you're going to plan. Because a lot of times what I would see from a lot of data engineers is they come to me and they say, well, we're going to build this whole framework to build all these pipelines, and it's all going to be orchestrated, and it's going to be like 10% more efficient than we do today. And then the real question is, okay, well, what does the business want out of it? Do they want to create their own pipelines? Do they just want the output in some form? Because if the business wants to create their own pipelines and they really need to be tweaking this logic on a day-to-day basis, the more complicated you make it, the worse it's going to be for the end user. And so something that I would harp on that is not a non-technical skill is taking the time and being able to understand what is the desired outcome of what you're about to do, of what you're doing with the data before jumping into actual solution. Because I'm sure everyone can give you a ton of advice on what hard skills to learn, but there are a lot of soft skills that you should have as a data engineer that would make you a lot more stand out from the crowd.
That's a co-founder talking, so I can definitely say yes. God. But Adi, what are your thoughts about it?
Yeah, I cannot agree more. Like being curious to really understand what's the data is used for, what is the data product, and who are the customers that you serve as an engineering company. I think it's one of the most important skills for a data engineer in order to make decisions around tools. And second thing, and that's for more people that want to get into that space, one of the commonality among the different tools is actually learning SQL. And sometimes it feels obvious, but many of the tools today are operating and leveraging SQL because they want to make their tools accessible to a lot of people. And SQL is kind of a common language to work with data. So like high level advice, always work on the soft skills and be curious around what exactly it is that we're building, so you can later on go back and really build a design doc and bringing the right tools at the right time to build the platform. And second advice, more for people who want to join that space, then SQL is something that you're probably going to see repeating itself in many tools.
Okay, pretty cool. Joy, Matt?
Yeah, I would say I can tell you how not to learn data engineering in 2022 and 2023. So you'll probably come across how do I become a data engineer? If you do a Google search, you'll probably come across articles that say you definitely need to learn Hadoop. You definitely need to learn Spark or any of these I would say old or complicated tools. And I would say approach it. I don't know. I think we're in agreement. The modern way to approach it is approach it from a life cycle standpoint. So understand the systems that generate data. Understand ways of ingesting data, storing it, and processing it, transforming it, and then serving it. And also the undercurrents of data engineering that we identify as data management, security, orchestration, the software engineering, architecture. These are all the big picture concepts. I think if you can, digest these concepts, that'll make you a stronger data engineer than maybe picking up a book and saying, okay, I'm going to learn, data engineering for, I don't know, using what's an esoteric tool.
I mean, I think Ray is a really cool up and coming tool, but it's also a bit esoteric right now. I wouldn't try to build my career on it just yet.
Yeah, so I wouldn't start out saying like a data engineering Ray handbook, right, or something like that. But it's not knocking backwards. But I would say just you got to avoid just the conversations where it's learn data engineering using X tool, right? X being a tool. I think it's a terrific way to, I think, distract you from a lot of the bigger picture concepts, and as well as from a technical angle. Adi points out SQL, right? That's sort of the lingua franca of data. If you know SQL, you're going to get Anantu, which is on our show just a few minutes ago.
We were just having
90% of the stuff you can do in SQL. Probably Python's another good language to learn, but I would say as well, as people pointed out, be curious, and also find. And Egor points out, learn how to understand what value you're going to add. This is as much as you have the word engineer in your title. Engineering is not what you were hired for. It's kind of a paradox, right? You're hired to produce things of value, ideally. Engineering is how you do this. but it's not an end-all be-all, right? Engineers have a tendency to want to engineer things, and I think too far often it's at the expense of actually understanding what it is that you're building and the value it provides. So it's a long-winded way of saying you should learn a lot of things. So.
Yeah.
Go ahead.
Love it. Also, problem solving, right? This is one of the big points. Is here you go. Here is a problem. Here's like a high level definition of what we want to achieve. Please solve it for us and design the workflow and everything around it and the features that you want to build. So yeah.
And to loop back to what you were saying as well, to add to what you were saying, Eddie, and what you said, Egor, it's also human problem solving, right? It's like working with the business, not only to get their requirements to say, hey, maybe you didn't think about this thing over here, communicate back, understand how to solve their business problem by working together, and then convert that into a technical solution as well.
Wow, this is fantastic. I know for a fact Ben was laughing there when you were mentioning about obviously how to unlearn or maybe don't learn data engineering, Joey. So Ben, would love to hear your thoughts there.
Yeah, I don't know if I was laughing for that or because I unplugged my mic. I was like, shoot. No, I mean, like, I guess I'll just kind of add a little bit more to this. Like, I think the one thing I recently heard that I really like is like, a lot of the technical skills will get you hired. A lot of the soft skills will get you promoted. So I think that's always an interesting way of thinking about it for anyone who's out there. Like, what skills should you learn? Personally, I always tell people, just make sure you have the basics first, learn a coding language that is being used heavily. Most people, I think, rely on Python right now for a lot of work. Obviously, there's some Scala, but I think Python still tends to be the heavier relied upon like language for a lot of DE kind of work. Obviously, learn SQL, learn a cloud service provider. Just pick one of the big three. More than likely, you can then transfer it to any of the other two. And then from there, just make sure you have a fundamental understanding of like data warehousing, the basics, where we've come, where we're going with it. And then from there, then the soft skills I think kind of come with that, right? Because like I think anyone when you first start out, like the soft skills are important, but you're still trying to like polish off your technical skills. So like you kind of need to start caring about them, but you kind of still need to be like, am I doing the right thing technically? And then like as you're kind of doing that, you start like ramping up and be like, okay, now let's talk about soft skills and actually asking like, why am I building this thing? Who's it for? What's the value it's going to add? Should I even build it? Should someone else build it? Should we find a solution? Should we find an open source solution? Should it be something that we're buying? And then that's when you start learning to ask those questions. I think part of it comes from the pain of building things from scratch and then realizing how much time it takes and how much time it takes after you've developed it and put it into production and be like, okay, now not only have I built this thing, I'm now expected to like continue to maintain it. If there's a problem, I have to fix it, or we have to hire more people to fix it. We have to expand upon it because people want more features. And so I think, you start learning that almost through the pain of being like, oh, I'm going to develop things myself. And then you're like, wow, that was a lot more work to do something very simple than I expected. So yeah, I think in terms of skills, you always make sure you've got that base level of skills, and then you can start building up kind of your other skills, whether it's technical or learning how to scale your impact, learning how to like be part of bigger decisions and ask more important questions. So that's my thoughts in terms of data engineering and skills.
Yeah, I think these are fantastic, explanation from each one of you. One thing that obviously I have understood here is it's not only just about, picking up a book and start learning data engineering. Like Joey mentioned, it's more on the lines where you need to be out there. Like Igor mentioned, okay, soft skills kind of play a very important role. If you start with SQL, it's one of the most important things, like Adi mentioned. And it's not only just limiting to, the data engineering that you go out and do that there, but how you're kind of creating the value for the business and how you're solving the problems for your client. That would actually matter a lot. So amazing insights here. Thanks a lot to everyone. Also, we have a few questions which I would like to take on from the audience here. One comment from Ben Castleton from Superconductor. He's missing this and this great party, and obviously a great convo. Agree, ELT was needed innovation, but doesn't replace ETL for all the use cases. Great comment from Igor there. So thanks for joining us, Ben, today. Also, there's LinkedIn user. I don't know if I am. It's Venkat. All right. So Venkat has a question for Igor. Do you see the data observability can fit as part of the CI/CD data pipeline, or is it a good fit for asynchronous monitoring of data post loads?
Ooh, this is a great question, and it introduces the word data observability, which I don't think we've covered here. So I'm just going to round out my trifecta and define data observability from my perspective, and then we can argue about that one as well.
Yes.
So the way that I see the correlation between data quality, data observability, and reliability is that observability is the over time perspective of this. Data changes over time because ETLs change, because there's new data that comes in, because business logic changes, and observability is the process of monitoring that over time and making sure it stays reliable and stays within the bounds that you would expect. So applying the rules, tracking them over time, understanding how they evolve is really part of that observability. The interesting part about the CI/CD part of the data pipeline, and I think the best example that we've run into of this is if someone's using DBT, they store their DBT in a GitHub repo and they make a new change to a model, and then that goes out, and then that might break the underlying assumptions about that model because that's used in a report, and the report assumes there's, like, for example, no dates in the future, but now there's dates in the future, and that might change something about the report itself. So using observability for that pipeline is really important because you can ensure that whatever you are changing as part of the PR in your data pipeline is not going to affect the downstream beyond what you intended to change. So a lot of times there's unintended consequences of changes to data pipelines. So if I misunderstood some logic and I added a filter that I thought was correct, but that actually ended up filtering out too many things, that is an unintended consequence that is usually caught after that went out. So using data observability as part of the CI pipeline is going to be a very powerful tool. So Bigeye actually has a feature called deltas, which helps you do this because it compares two different data sets and tells you how they differ. And so we've actually had our customers do exactly the same thing. We have a talk about this at DrakeCon coming up on Wednesday, Thursday. On Thursday, we have a talk from one of our customers who's going to tell you about how they are actually using Bigeye to do this CI sort of coverage. So tune into that if you're interested, or reach out to me as well. But it is possible. It is an important tool, and it can really help you get more reliable changes going out rather than guessing and then finding out from your end users that something is broken.
Yeah, that's fantastic. Thanks for that question. Venkat definitely brings out a lot of data observability from Igor. So thanks again. And we also have one interesting question from James here. And James is asking, does the business care if the pipelines are 10% more effective? Does that push the needle or any of their goals? What do you guys think? Maybe Ben? How about you start first?
I mean, if your pipelines are slow, I guess, then I'd imagine yes. But I mean, if your pipelines are already meeting their SLAs, then there might be other places you'd want to focus, right? Which is just going to be your current state, right? If your pipelines are taking 24 hours, then one, they probably want to see more than 10% change. But then 10% change would make a big deal. But on the flip side, if your pipelines are hitting their SLAs, rarely missing, they're on time, they're whatever, then there's obviously other places that you need to focus, like speed. Like, it's one of those things, I think as engineers, we love optimizing things, but to a certain point, there's good enough, you hit that point, and then you start focusing on other things, making the data more accessible, making it more usable by analysts, creating maybe something that's automatically surfacing metrics or alerting things. There's just other ways to drive value besides infrastructure for just infrastructure's sake kind of problems. So that's how I'd view it.
Yeah, I cannot agree more. It's always about optimization. Like, what are the business goals that we want to drive, right? What are the KPIs, OKR, whatever you would like to name it here, and then optimize. If you're hitting a target and you're good with your pipeline's effectiveness and good with SLA, there are probably other places where you want to optimize and build towards, because it's always the case with data systems and data platforms and businesses in general. So yeah.
Fantastic. Also, Joy, Matt?
I don't know. Another comment I would make is that in choosing tools, don't just focus on. There are things beyond even business deliverables. For example, if I'm choosing a cloud data warehouse or maybe like a Spark-based platform, what's the skill set of my team? How easy is it going to be for me to train that team? How easy is it going to be for me to find new engineers? Can I cross-train software developers within my company as data engineers? Especially right now in a talent shortage, you've got to think about these other aspects of tool selection as well, because that 10% typically in practice comes more down to the pipeline of data engineering projects, not the data processing itself, especially in the cloud where you can just buy more resources if you need to. It's the humans that become the constraint for business-oriented projects.
Yeah, I think it also depends on what effective means. I mean, it's sort of the, are you coming up with if there's 8-minute abs, are you coming up with 7-minute abs or 6-minute abs? It's a reference to an old school movie, but, it's like, I think it just depends. And, what does effective mean to you? So 10% more effective in a use case where it doesn't matter is 10% that I'd rather spend elsewhere. But if it's something that moves the needle, then sure. But again, I think to answer the second part, does that push the needle on any of the goals? It depends on the goals. So you can't universally say, oh yeah, data pipelines are 10% more effective, therefore it pushes goals. That's not really a tautology. So I think it's a very nuanced answer. But and then as Matt indicates, there's a lot of things that are outside of technology as well, again, skills and people and so forth. So other things. I don't know what those are, but every company's different, right?
Yeah. Egor, how do you look at it?
I actually caught on to something that Matt said that I think is it's an interesting trend that I see reversing right now in cloud infrastructure. Matt said that it's fine, just buy more compute in your cloud infrastructure, which is true. It is
to a point, right?
It is too easy to buy more compute in cloud infrastructure. I think a lot of people are finding that out the hard way, especially as they're looking at their Snowflake and Fivetran bills creep up and to the right. Those are a bit. If there is another way to look at it, which is if the business goal is actually, hey, we are spending way too much money on infrastructure and on overhead, and that bill is growing faster than anything else that we have in the business, then maybe making things more efficient from a compute perspective or timing perspective, maybe don't reprocess something 2 times a day, reprocess it once, but at the right time. That would actually push the needle on a lot of business goals that are even above the level of the data team. It's just at the business level, can we be more cost effective from an infrastructure perspective? And it's actually interesting. There's a lot of people discussing how to optimize your Snowflake build now, and how do we yeah, exactly.
We're going to talk about FinOps.
Yeah.
I was going to say this is the latest rage right now is cost controls and FinOps, financial operations, right? So so we don't have enough ops, so we need another one. But no, cost management is going to be, I think, especially kind of given the economic environment, this is going to be front and center for a lot of companies right now. So because you're absolutely right, Igor, you can't just gratuitously spend infinite amount of money in the cloud. You could, but I guess there's no infinite money. So
right. There's no cap on your spending with this kind of
I mean, the clouds love this, of course.
Clouds love this.
Do this. Yeah.
And I guess the point with FinOps. Oh, sorry, Adi, is that
No, go ahead. You finish, and then I'll have another.
There are 2 sides of the ledger in FinOps. So it's all about saving money, but also identifying hey, here's a really high value business use case. It makes sense to spend money over here. Go ahead. Sorry.
No, it's all good. Actually, I've been having multiple conversations with some customers that said it became tough to reserve compute on some of the cloud providers. So as the company grows, as they process a lot of data, as they need thousands of machines, there's actually a compute bottleneck even with cloud providers. So I don't know exactly which case we're discussing here, but efficiency can be that, hey, I cannot get any more compute even if I have the budget for it. So it can be like a really, really challenging problem when you say, hey, there's no more machines in the region, or the machines that I actually need in order to continue serving my customers.
I like to. I find this really interesting because I feel like when we are at the point where an organization starts asking, how do I process more things than a cloud operator will even allow me to process? You have to start asking questions around, are we even doing anything with all of that compute energy that we're using? Like, what is the actual end goal? Because I get it. Like, you can have a full-on machine learning platform, and any data scientist in the org can, like, retrain a new model and deploy it and retrain it like every hour. Is that actually doing anything? Is that model actually serving anything, or are we just retraining it every hour for the sake of retraining it because that's the default schedule and no one bothered to look?
Yep.
That's the interesting thing to me, and like having visibility into that is something that I'd be really curious to see if anyone's seen a good solution to that in the wild.
Well, it feels like this is kind of what happened in the peak Hadoop era. Like the data lake concept was just like dump it all in there and maybe do a lot of processing, and there must be some value in there somewhere versus like business value oriented data processing.
Awesome. I think these are great insights. Thanks for that question, James. And we've drifted through the topic, but amazing insights that everyone is sharing here. And I know for a fact that we have to do one raffle giveaway in sometimes just for the folks who have joined us. Quickly, what you can do is type in #Bigeye, and we'll be announcing both the winners towards the end so that we don't lose the momentum. I love this momentum where we are having so many insights together. So shifting gears here a bit, and obviously I know for a fact, Egor, you also mentioned that you guys are coming up with DrakeOn this week, and with DrakeOn, you'll be obviously focusing a lot on data reliability. So why not have that topic as well for today's discussion, where what is data reliability first thing, and why is it important in the data field? So maybe Egor, if you want to kick things off in terms of why is data reliability important?
Yeah. I mean, at the end of the day, I think we've all swirled around this notion of data. The data team needs to serve the business, and the outcomes need to be useful to the business that the organization that they're a part of. And so data reliability is talking about how do you make sure that that the things that you're building for the business are actually fit for use, that the business will look at them and say, yes, this makes sense to me, and I can use this to do something useful. And that now that we have all of this infrastructure and all of this tooling around getting data in, processing it, building out models, like creating data products, now data reliability is sort of that next hurdle of, okay, we're building all of these really cool things. How do we know that they're actually usable? And the thing that's really exciting to me is we have a speaker at DrakeOn named Mariah, and she is a data reliability engineer. And that is, it's I wouldn't say it's necessarily a different title. No, there's a lot of like weird titling things going on nowadays in data, but it is a role that needs to be performed in an organization that is very important. And we're getting into this interesting classification of data engineers into, there's a data reliability engineer, there's a data platform engineer that might be operating your actual infrastructure layer, there's like a data tooling engineer who is actually building the systems that you're creating your doing all your work in. And so in the same way that software engineering went through this specialization, the data landscape is going through the same specialization. And in the way that SRE fell out of software and infrastructure, data reliability engineers are falling out of the data engineering like monolith and turning into its own role.
Okay, that's amazing. Adi, what do you think about data reliability?
I think it's critical. I think we know how to do observability and monitoring for our compute and for our machines, right? So we have all the different log analytics tools and systems that we build, but we're completely missing out on having eyes on what's happening in our system from a data point of view, and making sure it is in good shape, so reliable, and also making sure, and this is something Joe said before, it's manageable, right? We need to manage that life cycle of different aspects where the data goes from, different high-level concept or high-level phases that the data goes through, in order to, until it's being consumed, until we sell it as a business or we provide it to an internal customer. So it definitely includes the reliability part of it, because once we have that life cycle, we want to be able to take actions and really see what is happening there. So 100%.
Yeah, I think assessing the reliability of data is kind of something which is super important, and that kind of makes a lot of difference there. But I'll let the question continue. Obviously, Joey, Matt, what do you guys think about data reliability?
I mean, I think it's a really, really hard problem. I often talk about data entropy, and that goes back to the conversation earlier about how you have quality now, will you have quality tomorrow? It's not clear, especially where you have just the modern data environment is so complicated, and so much of our data comes from outside of our walls. And so I'm frankly excited to see the whole slew of observability tools we have now, because they can solve this problem in a variety of ways. So first you have just the foundational, like, is the basic logic correct? Are there nulls where they're not supposed to be? But also just monitoring, is my data drifting? Is there am I going out of bounds on expected statistics? Am I somehow going out of an expected Poisson distribution for how much of a certain type of event we should have? And I think this is it remains a really, really hard problem, but this is like the future of data engineering.
Well, especially watermarking your initial, what is reliable, right?
Yeah.
This isn't some like navel gazing question. This is actually a pretty important question. What do when you say reliability, what exactly are you staking as what is reliable, what is not in your process? And so this is, it's, I'm very stoked on this though. I think it's a good ideal to get to. And I feel like we're just in the very early innings of this. I mean, just consider that 3 years ago, really most companies weren't talking about this, right? Or whatever made up number, 3.5, 4, whatever. But the thing is, this was not a conversation, right? It was all about, let's do things in a data warehouse. And people start doing things in the data warehouse, and they're like, oh crap, things are wrong in the data warehouse. Let's fix that. So I think these are all great steps. And I'm excited to see what happens.
I feel like behind the scenes, there were a lot of conversations going on. I mean, every organization I've worked inside, you talk to a bunch of people and they're like, oh yeah, this table has this data quality issue and this table has this data quality issue.
It was kind of like,
it was very
like dirty family secrets or something,
exactly.
Right? It's like, you don't really, don't talk about that. That's, we'll put that,
It used to be more tribal knowledge. You used to have, you had an analyst on the team that said, "Oh yeah, that is a known problem. I just filter out that data every time I run an analysis." And and then that just repeated itself 100 times within an organization. And now we're just saying that we're acknowledging the fact that has always existed, and now are building processes and tools in order to manage that and understand that better.
I mean, my litmus test would always be to look at, if I could look at your SQL code, and there's like your where clauses are they're very subtle, right? It's like, there's a lot of interesting conditions here that would only indicate that this is because you're trying to duct tape something, right?
And then some data scientist would jump in on that table and try to make sense of it, and they would just get these bizarre results because they weren't doing the appropriate filtering.
What do you think, Ben?
I mean, I think I was going to add in, it's almost like a necessity in order to scale, right? Like data reliability. It's like, in my experience, when you start building pipelines, especially if you work at like a large tech organization, because that's how you drive impact. And then the more pipelines you start to create, you realize the more you have to manage, right? Like over time, you're like, oh, all those pipelines are now things that I'm responsible for. And without things like data reliability or some sort of solution that can manage that, it almost becomes just your job to make sure that those pipelines are producing accurate data. Because if they fail, like someone's going to come at you. And one, if you don't know what's constantly failing, right? So there's sometimes just like that constant failure. You're not going to know what to fix because it just feels like every day you're fixing something new. And then two, hopefully these things are hopefully telling you before there are problems or as the problem is occurring. So that way you can start, directing fixes to it rather than constantly firefighting. So I feel like it's kind of an important step in the whole avoiding firefighting as a data engineer, which just seems to be our constant thing, right? Someone changed something upstream. Now we have to make a change to a pipeline. And so, someone who's done a lot of that work over time, it's great to have something that like tells you ahead of time. I have all those little things that like make sure that your data is reliable as a whole, and not just, trying to build new pipelines. So yeah, I mean, I think it's like necessary if you're going to try scaling and make more complex pipelines. I also really like that where clause statement. It's like, yeah, whenever you see that, you're always like, yeah. And then, I think we might have all tried to fix it at the source, but sometimes you're just stuck being like, and I have to write this annoying little where clause. I think the one thing there is like, hopefully that like your final layer of data, whatever the analysts are seeing, are hopefully beyond that, right? Like hopefully they're not seeing the where clause raw data. Hopefully they're seeing the more productionized data set that's somewhat cleaned. Yeah.
We always use a lot of terminology for plumbing too, and I always, it's like pipelines and stuff like that. And what I find interesting is, okay, so if you take the example of like reliable plumbing, right? You don't know it just works, right? I think that's how we should view like the ideal state in which we should be working, right? Firefighting, for example, if you're firefighting as a plumber, if you're responding to plumbing emergencies like nonstop in a building you're maintaining, that would look really bad for you, I would say, right? And there's no glory in that. If you're a plumber and you keep, stuff keeps breaking all the time, that doesn't sound like a lot of fun. I don't know. Maybe you think it would be fun.
No. I mean, it's kind of like if you have that many plumbing problems in a building, then it's a sign you're eventually going to have a very serious flood, right? And same thing, if you're having these data problems all the time and can't get them under control, it might be a sign of bad organizational health on the data side of the company or other parts of the company even. Mm-hmm.
You have to deal with the day-to-day and miss completely on the long-term vision and growth. So yeah.
For sure.
Something that I also want to call out is, I know we talk a lot about becoming data engineers, and I just want to, something that I have always said is, I feel like a bit of a masochist because I enjoy the data space. Like, I don't think anybody data is not always fun. It is interesting. It is definitely interesting. It is creative. There's a lot of innovation. It is one of the fastest growing sectors in tech. But I have to say it is very often not fun because of a lot of these things that we're talking about now, because of institutionalized knowledge, tools that are difficult to use, a lot of paradigms that no one can agree on which one's the best to use. And so every organization is going to do something slightly different. Even within an organization, you might have multiple paradigms that are competing. And so there's just something there where like, data is very interesting, and if you're out there and you feel like my data team is so disorganized, there's no way that everyone is like this, I can reassure you, everyone is like this. Every organization, from the smallest to the biggest, has some skeletons in their data closets, and you're not alone in this. And that's why we have these sorts of support groups, effectively, for all of us data people.
Ravit, maybe flash up James's comment.
Exactly. That's what I was wondering. He just says, I remember that the finance team once said we have always been $200,000 off on legacy daily report, but now it is $500,000. We can't handle that. My thought was, why didn't you tell me about the original problem, and it would have never gotten to $500,000. Has that ever happened to you guys? Ever? Wondering.
Yeah, I mean, how, like, at what stage do you actually take care of the problem, right?
Mm.
How do you optimize? Like, what is the first thing that you work on? Is that a long-term? Is that a long-term feature or a long-term change that you need to introduce into the legacy system? Or is that like something that a firefighter can take off like immediately? So.
Yep. I think y'all are the best engineers, so I'm sure y'all have handled it in the early stage itself. So y'all didn't reach to a $500,000 there, but yeah, awesome.
It would only be 450,000, not 500. We're not
10% better.
Yeah.
Awesome. We have one follow-up question on the data observability bit. I think it's from Aruna. Do the data observability tools ultimately provide the reliable data, or is it some other methodologies available to ensure the ultimate correctness of data? Egor, maybe you can take this one.
A tool can never solve the whole problem. Just because you have a data observability tool, just because you're tracking the state of your data, does not mean that your data is reliable. There is a second bit that you need to have, which is the processes within the organizations in order to respond to changes in the state of your data. So here's a good example. I think Joe or Matt were talking about nulls. Let's say you have a table and you have a user ID column and it's never null, and all of a sudden you see some number of nulls creeping in. Great. A data observability tool is going to tell you that there are now nulls in your user ID column. But what are you going to do about it? Is anyone even looking at that? Does anyone know where that data is coming from? Do they know how to fix it? Do they know who should fix it? And those are the sorts of processes that you need to have in place in order to triage and respond to issues in data reliability. Otherwise, just the process of observing it isn't actually going to do you any good. And so this is why whenever I talk about data reliability, I talk about both tools and processes. The human processes are probably more important than the tools that you use. The tools are doing a job and they're showing you something, they're allowing you to be more efficient at a certain step in the process. But the process itself is the important part.
Interesting. Joy, what are your thoughts?
I mean, I absolutely agree. I mean, I would say that maybe when machines are just producing data and there's no humans involved, then maybe you can get to the point where technology self-heals itself. But until then, if humans are generating data, then it's kind of like, have fun with that. And even then, if it's all, machine generated, it's still there's still unknown issues that could happen. So we always look at things to like Egor pointed out, people, process, and technology. So it's always something, here's the thing, nobody like deliberately really wants to have unreliable data, right? Or like bad data. Maybe if you're a malicious actor, I could make an argument for that. But if you're on the straight and narrow and stuff, I mean, you're still probably going to make mistakes. I mean, geez, what was that 2013 article Harvard Business Review had about Excel and how Excel, it was like 80 to 90% of Excel reports have errors in them. So, and Excel, I think, is the biggest data platform there is. So you can't get that right. In tools where people are making decisions off this all day. I kind of consider, as a tangent, I consider Excel to be like this. We talk about the modern data stack, right? There's this other whole universe, this parallel universe of Excel reports that nobody seems to talk about. But yeah, I don't think anyone intends this to happen. It just happens. You got to be able to deal with it. But that's as much of a process and people issue as it is technology. So.
Yeah, and to me, what I'll add is the data observability is a prerequisite. So in other words, we talked earlier about data reliability. Well, if you're not detecting, for example, quality problems, then what's your recovery time objective going to be? I mean, who knows? I've seen it take months for teams to detect data problems, and so nothing can get fixed until there's.
I've seen years.
Sometimes years, but at least if you're detecting problems, then you can start thinking about your operational incident response at that point, building data ops processes. Yeah.
Mm-hmm.
Yeah, and also one of the points that actually our audience asked before about the CI/CD for data pipelines. I think it's really interesting, Igor, what you mentioned. We want to enable continuous integration of the data into our systems. In that point of time, we can actually also introduce some hooks in order to ensure the correctness of the data, and then based on these hooks, introduce more business logic, like what do we want to do with this data that now that we know it introduces nulls into the system and there shouldn't be any nulls there. Should we wake up one of the engineers? Should we stop the pipeline or altogether? Should we let the data just flow because it's better to have high availability of the data product itself? So I think there's a lot of interesting conversations, and one of the methodological available is actually to introduce that CI/CD for data in order to test it and make a decision based on the correctness of data that flows in our production systems.
Pretty interesting, those insights. So also we have a comment from Susan here. She's like, I need data problems to stay in the business. So there are a lot of folks who would definitely need more data problems to happen for them to run the business. So Susan, thanks for that comment. Also, a very interesting question that I got some time back, and I would love to hear everyone's thoughts here on this one. Aditi is asking, what's an ideal modern data stack? We see so many different versions out there. So would love to hear from you guys. I guess Adi will join us. Maybe, I don't think she has a hard stop, so maybe by mistake. But yeah, maybe Ben, why don't you start? I know for a fact you talk a lot around modern data stack, about the things that are going around. So would love to hear your thoughts.
I mean, I think generally when I talk about it, I'm usually like, well, just make sure you've got the baseline set up more than anything else. Generally that involves like ingestion, storage, visualization, and then hopefully data quality and observability and some sort of data reliability. But I've always found that comes in when there's a problem. Most people are just focused on very much on the ingestion, storage, and then analytics side first, and then they're like, we'll do, we'll figure out data quality when we actually have a problem, which then can lead to, as referenced earlier, 3 years of not knowing you have a problem. So, it's more funny than anything else, actually. Not to just quickly reference the Excel comment. You can just Google like Excel mistakes that have cost millions, if not billions of dollars. And there's at least, I think, like 6 to 10 cases where it's like there have been like just obvious cases where like it was an Excel mistake that has like caused people to report inaccurate finances that then majorly impacts stock price when you have to correct it, or cause people to buy the wrong like set of like derivatives or something of that nature, and then again cost billions of dollars to something like JP Morgan. So more just funny, but yeah, I mean, like, the right stacks, it's just always going to be so different for different people. If you've got one, I've always noticed that like the modern data stack to me often feels more like an SMB mid-market space, whereas then like as I start going up the chain, like enterprise, they still tend to use a very different set of tools. Maybe they're building their own tools altogether because they've got enough engineering hands, or maybe they're using something like like Azure Data Factory and those toolings because they've got deals with Azure or AWS. And so I've always noticed that like the modern data stack in itself tends to lean more towards the SMB and mid-market space. And even there, it's going to depend on how many people you have helping build it, right? Like the larger your staff, the more maybe open source you can be if that's what you like doing. Or if you've got a small staff, you're gonna have to use a lot of solutions to kind of make up for that gap. So I rarely have a clear answer on this, because to me it's just gonna be like, well, what team do you have? What are the problems you're trying to solve? What's their skill set? There's just a lot of other questions that come into play first before you can answer like these are the tools that are going to fit best for you. And it always changes. Like I think there are certain solutions that I've picked maybe 2 years ago that I'm now like, oh, these are actually kind of expensive. And if you're using maybe a simpler use case, you can actually switch over here, and this would reduce your bill, like your cloud bill, considerably. So it's always just, there's too many dependencies for me to like answer that in one 3-minute answer.
Yeah, very true. And I know for a fact, Ben, you also, if I'm not wrong, you kind of created a video also around the JP Morgan, the error about how it all went wrong with these companies on your YouTube channel, if I'm not wrong.
Yeah, that's definitely one of my lesser viewed videos. But yes, I definitely created I think it was whatever 5 Excel errors that cost companies millions or something. So yes, thank you for the plug.
Yeah, definitely. For the folks, obviously, who haven't been following Ben on the YouTube, it's Seattle Data. Go check him out. He's creating great stuff. And also, Suzanne here mentions that she has that in her book, and this is the book. Actually, I had it handy because I was just going through it, and thanks for that, Suzanne. Amazing book and great stuff that you're doing. So, Adi, welcome back. Would love to hear your thoughts around modern data stack and the different versions. Yeah.
Yeah, I think, the main key point to kind of keep in mind is agile, right? As we develop software, as we develop platforms, as we develop solution, we need to keep an agile way of doing things. We cannot jump immediately into building the best, infrastructure, because that does not exist, and there's no the best in modern data platform. It's always what are your needs, what do you want to achieve, etc., and then how we can slowly iterate on it in an agile manner while still serving the product managers, still serving the sales engineers, so they'll have something to sell, and the product manager will have something to pitch. So we always we have a couple of features that we giving customers, internal or external, while still developing the infrastructure and developing the system as we grow. I think one of the biggest issues or concerns I've seen with engineers is too much engineering. It's we have to prepare that path for that future feature that will come in, and we have to make sure we're baking in, I don't know, some different things, and then different companies with different engineering team. It actually slows down the organization as a whole, and also slows down the whole system. So a good engineering manager, a good engineering VP of engineering or lead engineering will think through together with the product, what are the critical features that we need right now? How can we deliver on our promise and still give enough time for the engineers to do these cycles of agile development in order to slowly grow into the data infrastructure that they need. And even at that point, that data infrastructure would consider legacy. So everything all the code that we just developed is legacy from the minute we finished writing it. So take that into account when you think about what is the modern data stack, or how should our modern data platform should look like, because it's not going to be modern by the time you finish doing that specific integration anymore. So it's like a nice phrase or a nice term to use. But just some things to keep in mind as you iterate, like build a bike and then build a car and then build a plane, but don't build the whale or just the engine itself without actually making sure you're providing features to the users.
Fantastic approach there. Yeah, Adi, I like the agile approach that you have, and at the same time where you say that things are kind of ever evolving, and I love the example there. I might use it somewhere at least. So Egor, what are your thoughts around modern data stack and the different versions that we see?
Oh boy, Joe's laughing over there. He's like, here we go, asking a modern data stack vendor for his opinion on modern data stack. No, okay,
That's great.
Exactly.
I'll be fairly as objective as possible in this case. The way that I see, I do not think that there is one ideal modern data stack. I think what the term modern data stack has done is it has created a description of the unbundling of data tooling that has happened over the last couple of years. And it has created categories of problems that need to be solved within a data team that can then be addressed by tools that are purpose fit for that job. So here's a good example. The typical, I'm going to make the, I am in no way endorsing any of these companies by saying this, but the classic modern data stack today is Snowflake, Fivetran, DBT, and then probably Looker or Tableau or Mode or one of those, right? So you have your infrastructure, you have your ingest layer from raw to your warehouse, you have your transformation layer, and then you have your reporting layer. Now, the fact that there are even layers, I think that's really what the modern data stack is trying to represent, is to say, like, look, there are going to be things that you need to solve, problems you need to solve across the in the data space that can be addressed by different tools. And then you can start layering as your problem space grows larger, as your team grows larger, and then you have bigger problems, then you can find another category that fits that problem fits in order to quickly understand what tools and what types of solutions are good for that problem domain. And a good example here is, to Ben's point, teams don't start with data observability. If you don't have data, you have nothing to observe. So then what's the point? You start with, like, give me my infrastructure and let me get data in and let me start reporting on it. Let me start using it. And then once I use it, I need it to be reliable. Then you kind of go for data reliability. And once you get to that point where, oh, my data is not reliable, now what? You look at the modern data stack map and then you say, okay, well, what section encompasses this problem? Oh, it's the data observability section. Great, let me go look there. Then you get too big and there's too much domain knowledge and it's all spread out across teams. And now you're like, well, how do I find the right data to use for any purpose? Well, now you need a data catalog, and great, that problem is addressed by the data catalog circle. And that's what I see the modern data stack as being, is breaking down your problems into domains and then mapping them into those domains and understanding what tools can help you solve those problems. I don't think there's one ideal stack, because I think it depends on your business needs, and there's a lot of companies in each of these buckets and they do different things well, and you have to pick the right thing for your organization. But that is where I see the value in the modern data stack, and so I'm happy to take comments on that one. But I don't think there is one ideal solution here.
I think there's a lot of cargo culting too with data stacks, right? I think the modern data stack ain't even that modern anymore. I mean, if you look at sort of the genesis of the criteria of, I think the original criteria of a modern data stack was cloud native, preferably SaaS-based tools. I mean, you can make an argument that Redshift really ushered this in 2012, right? I mean, it was the first time you had I think a cloud-based data warehouse that was democratized for the every person and so forth. And so the democratization of tools, I think, is really what I think the modern data stack brought to the world, and it's a great thing. And with great things come greater responsibilities and greater complexities. But what my ideal data stack really, and Matt, feel free to chime in. But I think it's what we kind of nerd out and call the live data stack. I think this is with the rise of streaming, and I think we're starting to see a lot of efforts being moved back to the application layer. I think over the next few years, you're going to see software engineering being more, I would say, tightly bundled with what is now data engineering, and a tighter feedback loop between application products and what we now call data products. So these might be maybe embedded dashboards, for example, in an application, or machine learning, all the above. But the notion that you have to have sort of a data warehouse that sits in the middle of everything, I think that this, at least Matt and I will challenge this notion, I would say, and I think there's it'll evolve. I think there's still room for the existing paradigm that we have, but I think from what we're seeing, it's changing in real time, no pun intended. But so what's modern today will be different later. And as Addy points out too, everything is legacy the moment you write it, and legacy gets a bad rap. I think I heard somebody say once that legacy is it's a condescending way of describing things that make money.
Mm-hmm.
So legacy is good. But legacy is
I actually attended a great session in one of the recent conferences. It's like conference season now, and another one is coming up. That they spoke about actually that we solved a lot of the problems around data. So we know how to scale, we know how to do that compute, we know all of this good stuff. And now the challenge is actually how to manage all of that. So the observability way, the fact that we have corrupted data, or we need to clean our data, or correctness of our data. GDPR, all the different compliances, etc. So absolutely, 100%. It feels like we are evolving as an industry, Like we know how to compute, how to run compute and operate and transform petabyte of data. We know how to do it. We know how to scale out. Now the more challenging aspect is how do you piece all these things together and still be able to observe it, right? Be able to take actions on top of really see what's happening in your system.
And right now we're only observing, I think, a small fraction of the entire universe, right? And so it's again, I think the feedback loop is really going to start from applications and source data and all the way through the life cycle. I think that's the next phase where it goes, and this becomes a very tight feedback loop. So the time to response, and the time to value is shortened significantly. And so, hi, Kitty. So that's I would say that's my ideal data stack. I'm very impatient. I like tight feedback loops. So why do I need to wait for an answer for days when I can just get it in minutes or seconds, right? So ultimately, it depends on what you're trying to achieve as an outcome, of course, Matt. But
yeah, and I'll just follow into what Adi was saying too. In our book, we actually refer to exactly what you're talking about, this evolution. We call this enterprise-y data engineering.
Yep.
And of course, that the term enterprise is kind of off-putting, but the reality is that tools like Bigeye are intended to address these more abstract issues that are actually really, really hard that organizations have been ignoring for maybe the last 20 years. Unless they're a big enterprise and they have like a team to work on them.
But now everybody is an enterprise.
Now everyone is kind of a mini enterprise. Yeah.
The enterprise of you. Yes.
So, something that I wanna follow up on is, Adi said that as soon as you build something, it turns into legacy software, and then Joe said legacy is really just what makes money. And I think there's an interesting corollary, which is legacy software is software that's actually being used to solve a problem.
Bingo.
Once it's written and once it's put in use, it is solving a problem. And I don't necessarily see legacy as it shouldn't be a bad term. Like, being interoperable with legacy technology shouldn't be a bad thing. It means you can actually, if anything, you can better help people migrate into something that's maybe more efficient, more scalable, more expressible, because it's a little bit more modern. But if you never reach back to the people who are using existing technology to solve existing problems, you're never going to get everyone's attention. If you're just only looking forward rather than trying to also understand the existing problems, I don't think that's the right way to solve any problem either.
Amazing. I think these are fantastic insights that everyone has brought to the table. Obviously, I know for a fact we have limited time, but let's do the quick raffle for our audience who have participated in the Bigeye swag. And here we go. Let's do the quick drum roll here. Oh, my name can come up as well. Do I win, Egor?
If you win, you can re-roll again, and then we'll send you swag anyways. We'll send everyone on this panel swag.
All right. The first winner is Aditi. Congratulations. Also, you asked a great question around modern data stack, so totally worth it. Let's see who the second winner is. And the second winner is Ravinder Singh. Congratulations from YouTube. Feel free to follow up with me and we can get the ball rolling. All right, I'll remove this. And there's one interesting question for you, Egor, in the chat. And this one's interesting. As data observability is closely aligned with bringing confidence into data, what roles data stewards play with the tools under data governance ecosystem? Where and how does Bigeye platform fits the bill?
Yeah, so this is a great question. There is obviously a lot of really tight interaction between data observability and data governance, because data governance is aimed at understanding what data do you have, what is it being used for, and what is the state of it, and how do you communicate that out to the organization. Whereas data observability says, is this data fit for use? Is it matching your expectations? And so that is more information that you feed into the rest of your data governance platform. This is how I see Bigeye and a lot of the other data observability tools fit into this is they feed information into the data governance ecosystem. They say, here is what we know about this data. Here are the expectations that you have around it. Here is how you're tracking its health, and this is how reliable it is. And then you can surface that as in your data governance tools and through your data governance processes. Data stewards are important on both sides of the fence now, because on one hand, you need to manage the data governance ecosystem. On the other hand, you know the data the best, and you know who's using it and how and why. And you can use that information in order to define what reliable even means and define what things you want to observe and how. Because a lot of times teams have a hard time bridging that gap of the users of the data have the knowledge about what they expect the data to look like. And whereas the producers of the data engineers, are the ones who are building the pipeline, making sure it's going there, the data's landing, but they may not always have the downstream knowledge of what is this data being used for and how do I define reliability around it. And so this is where data stewards can pitch in on both sides and make the whole system better.
Amazing. Nice question from Venkat there. Thanks for that, Venkat. I know for a fact within this panel, there are a lot of authors and the books I'm making around data engineering. I know, Adi, you're writing a book. I know, Joey, Matt, you guys are writing a book. Would love to hear a little about the books that are coming up and how do you guys keep that up to date? Because data engineering space is ever evolving. We know that. And how does that process work? Maybe, Adi, you can share where are you, in which stage are you in the book, and how is it coming together?
Yeah, so I'm writing a book about machine learning with Spark, and then how to expand and build a data layer actually to bridge into TensorFlow and PyTorch, the distributed parts of TensorFlow and PyTorch. So how do they create the execution graph? How do they operate? What's the networking under the hood, etc. So it's close to finish. There's a couple of cycles more with O'Reilly. There's always, the O'Reilly team is very engaged. I'm sure everyone here are nodding. The people that works with O'Reilly, they're very much engaged and very much want to make sure the content is in a good place. There's a good storytelling baked into it, etc. There is an online copy available. Not all the chapters there, but soon, in a month or so, all the chapters will be there. And then the hard copy would come out early next year. So early 2023.
Congrats.
Congratulations. And what I'll do is I'll share a link with the folks in the chat so they can have a look at the book as well. Joy, why not tell us about your experience? Joy, Matt.
Yeah. This book was hard. Even when we proposed it to O'Reilly, they were like, "You're kind of crazy. Why would you write this book?" I'm like, "I don't know, because we're wild and crazy guys, I guess." So it was, yeah. I mean, it would. I think we wanted to take the approach of, okay, so what would a book look like that's going to be relevant, several years from now in data engineering, not just something that might potentially be, out of date by the time it goes to print. Because I don't know, we spent a lot of time on this book, so we want to make sure it's, at least we tried to read it. And so what we really, is a matter of peeling back, okay, so what's not going to change really, right? And I think like there's certain attributes of, say, understanding source systems, understanding, data ingestion patterns, understanding storage and transformations, how do queries work, and all this other stuff. Like these are fundamentals that I would say are less, they're more immutable, and I think less likely to alteration or trends. And so that was really the crux of even figuring out what that looked like. Once we started writing, I would say, I think 90% of our time was spent researching or reading, and then 10% writing. And seeing as it's between 400 and 450 pages, you can kind of imagine how much effort went into this. So it's fun, but we're in the finishing stages. Our wonderful editors at O'Reilly are in the process of, I think, finalizing the proofs of everything, and expect the book to be released, I think, as soon as August, if things go well. I guess it depends on how Matt and I get things.
Yeah, I read the entire book. The previous weekend, and then once the PDF proofs come back, we have to read the entire book after June 1st, and then do it again. Like it's this multi-stage.
Yeah,
thing.
Saudi, your work is not over.
Yeah.
Not by any stretch of the imagination.
But what I'll add here is it will definitely go out of date, right? Every book does. We try
Yeah.
to keep it fairly. I think our intention was to write a book that was more complementary to a lot of the existing O'Reilly library and to books on technologies like the one you're writing, Adi, so that you can turn to those books when you need to understand, like, how do I actually build concretely a pipeline with this technology versus how do I think about the entire life cycle? What are the big problems of data engineering? Or even how do I choose technologies? There are a lot of technologies out there. How do I pick the right ones to integrate it into my pipeline?
Yeah, I mean, we took inspiration from Martin Kleppman's book for sure. I think that book is sort of withstood the test of time of designing data-intensive applications. I think it's still the #1 seller in data right now. So that shows you where the industry is actually, that designing data-intensive applications is like the least riveting title in the universe. And that's like a bestseller. That's crazy. I can think of far more boring sounding titles, but that's among them. So what were you going to say, Dottie?
Yeah, I think it introduced a lot of concept that existed only in specific companies that were already digesting that idea of the distributed approaches and etc. The intense data applications, and also mixed with research, right? Because at the end of the day, he's the author that works on that has a PhD and also teaches it on a daily basis. So it also introduced a lot of concept that's coming from research and innovation, which was really interesting to see. So I'm excited for your book.
Thanks. Likewise. Yeah, it was kind of interesting. Martin reviewed our book too, and it's the first thing he said in his notes, like, "I'm definitely an academic, not a practitioner." And we're like, so it was definitely getting great feedback. But it was cool getting that distinction. But yeah, congrats on your book too. Maybe we'll do a book party.
That sounds great. We should do a podcast talking about the experience of writing a book. Actually, O'Reilly has asked us to do something like that, so maybe we could get a couple of O'Reilly authors together on a panel or something.
Yeah.
Wow. That's so cool.
Yeah.
Can't wait to see that panel. Yeah. But congratulations, both of you.
Thank you.
Obviously, I know for a fact where Joey, your book was #1 release on Amazon. Once it was in the pre-order stage already. So can't wait to see that same for Adi as well. And more power to all the authors. I know for a fact Ben is out there, and I'm sure he has like a pile up of videos that might be coming in, and he does a lot of his newsletters out there are fantastic. So Ben, tell us more about what's coming next for you.
I mean, more newsletters. I think I just pressed my audio again.
Okay, fantastic. All right.
Still there, Ben?
Ben, you're muted. Ben is around the windows, I guess. But
okay. He has great. He kills it with the content, though.
He really does.
Got mad respect for Ben. So
I
exactly.
recommend his
He
content.
sits over content and so much content. It's like endless newsletters that I see coming from his end. The LinkedIn post, he started writing so much. I love his content out there. Egor, there's a big week. This week is super big for you. We would love to know more about DrakeOn, about what's happening there, what you guys have created, who are the speakers. And also I'll share a link with the folks. I can actually, you can tell us more about it, and I can share the screen and also let the folks know more about DrakeOn.
Yeah, definitely. So DrakeOn is our annual conference that we host. We held one last year in December, and we had over 1,000 attendees, and we're really excited to host it again this year. We're doing a couple of things a little bit differently this year. We are going to have a live workshop hosted by myself. I am going to show you how to build a basic data observability platform in under 2 hours purely on Snowflake. I use no tool other than Snowflake. It is actually, wow. I'm very excited about it. And on Thursday, we're going to have a Q&A with a live Q&A with some folks from the speaker list so that you can join. We are running this conference as a community event. This is not meant to necessarily promote any individual product. This is more about concepts around data reliability, how are teams dealing with data reliability, what are the tools and processes that they are using. Like we talked about, processes are really important. And last time we had Drake on, a lot of the feedback that I heard was that people were really interested in knowing, how do other teams deal with their data platforms, and what kind of processes do they use in order to deploy new code, and how do they build reliability into their pipelines? And this is something that is an interesting way to learn about what's going on in other organizations, and how do they deal with the same problems that you may be facing yourself. So definitely looking forward to it. Lots of great speakers from a lot of different industries and a lot of different company sizes, from very small to very large. So tune in and find out what's going on around the industry.
Sounds like a plan. I know for a fact it will be a big hit. I've already, I've seen a lot of data engineering folks already registering for it. So all the best on that, Egor. Great stuff. I think we're close to time, and actually over the time, but I didn't want to obviously cut on the conversation. It's one of the most interesting session that I've had, and I would love to have you guys again. Maybe not virtually, but we might do this physically, and we'll have more folks under the table, and we can have some great chat around it. So thanks again, everyone, for joining us today. Egor, Joy, Matt, Ben, Adi, it was such fun to have you guys on the Ravit Show, and like I said, can't wait to do this again. Maybe virtually, but more intending to visit you guys and do it physically. We can, if possible, why not? Yeah.
Sounds good.
Thank you.
Cool.
All right.
you.
Thank you, everyone,
Thanks,
for
everybody.
joining us today.
Yep.
See you guys.
All right. Bye.
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 Thank you.